The drone feed flickered once, then locked. Somewhere in the Donetsk Oblast, a Ukrainian reconnaissance operator leaned toward his screen and watched a shape emerge from tree cover. Not a tank, not a BMP. Something far larger, a self-propelled gun the length of a city bus, its barrel extending nearly 11 meters, its hull trailing exhaust as it lumbered into a prepared firing position. The operator recognized it immediately. The 2S7 Pion. 203 millimeters of Cold War engineering. One of the heaviest artillery pieces Russia still fields in open combat. He did not call for immediate fire. He waited. He needed the gun to shoot first, because the moment that barrel elevated and the breech slammed shut, everything downstream would move fast. Acoustic sensors, counter-battery radar, a HIMARS crew already warm, already waiting. The Pion had maybe 8 minutes from first shot to first incoming round, maybe less. What follows, reconstructed from open-source evidence, Oryx documented wreckage, geolocated strike footage, and intercepted Russian logistic communications, is how Ukraine turned those 8 minutes into a systematic campaign that destroyed at least 15 2S7 Pion and 2S7M Malka heavy self-propelled guns across the Donbas front through 2024 and into 2025. 15 of the largest guns Russia brought to this war. Gone, confirmed, photographed in pieces. The question is not simply how Ukraine hit them. The question is why Russia kept sending them forward, and what their loss means for Moscow's ability to reach deep into Ukrainian-held territory. That answer is more consequential than most Western analysts have acknowledged, and it begins not with the gun itself, but with the doctrine built around it. The 2S7 Pion, its name means peony in Russian, though there is nothing delicate about it, entered Soviet service in 1975. It was designed for one specific mission: nuclear artillery delivery. The original variants could fire a 110-kilogram conventional shell to roughly 37 kilometers, but the platform was built around the possibility of launching a tactical nuclear projectile deep into NATO rear areas. The nuclear mission faded with the Cold War, but the gun stayed in service because its conventional deep fires capability was unmatched in the Russian inventory. The modernized 2S7M Malka, which entered service in the late 1980s and was upgraded through the 1990s, pushed maximum range to roughly 47 kilometers using rocket-assisted projectiles. At that range, a Pion battery positioned well behind the front line could reach Ukrainian logistics nodes, command posts, ammunition depots, and railway junctions that shorter-range artillery simply could not touch. The 203mm shell itself, each round weighing over 100 kilograms, delivers catastrophic terminal effects. A single hit on a lightly protected structure is effectively a demolition strike. Against field fortifications, the penetration and blast radius exceeds anything a 152mm or 155mm round can produce. Russia entered the full-scale invasion in February 2022 with roughly 60 Pion and Malka systems believed to be in active inventory, with additional units theoretically held in long-term storage. The actual combat-ready number at the war's start was almost certainly lower. Russian maintenance standards for complex legacy platforms are notoriously poor, and many storage-held vehicles had sat for years without proper preservation. Still, even a partial deployment gave Russia something genuinely dangerous: a gun that could strike from positions so far behind the forward line that Ukrainian counter-battery systems struggled to reach it. That advantage held through much of 2022 and into 2023. Then Ukraine began to adapt. Here is the part that does not make sense on the surface. The Pion was supposed to be safe precisely because of its range. You park at 35 kilometers from the front, fire, and the enemy's counter-battery radar cannot cue anything with enough reach to respond. For most of the war's first phase, that logic held. Ukrainian artillery was concentrated on the immediate contact line. Long-range HIMARS strikes were focused on ammunition depots and bridges, not on individual artillery systems positioned deep in Russian-controlled territory. What changed was the kill chain itself. Not a single new weapon, but a systematic integration of sensors, data processing, and strike assets that compressed the time between detection and impact to the point where the Pion's slow displacement speed became a fatal vulnerability. Consider what Russian counter-battery doctrine actually required the Pion crew to do. Fire, reload, a slow process on a 203mm system. Trained crews need several minutes per round. Displace. The gun weighs nearly 46 tons. It moves on tracks at a maximum road speed of around 50 kilometers per hour, but across the cratered, muddy terrain common to eastern Ukrainian firing positions, realistic displacement speed is far lower. The crew needs to limber up equipment, clear the position, and move to a pre-selected alternate firing point that itself must be surveyed in advance. In the 2022 paradigm, that was manageable. In the 2024 paradigm, it was not. By late 2023 and into 2024, Ukrainian forces had significantly expanded their persistent drone reconnaissance capability over Russian rear areas. Aero-Rozvidka units and associated drone operators were flying extended endurance ISR missions specifically designed to map Russian artillery patterns, not just where guns fired from, but where they displaced to. Pre-surveyed alternate positions, ammunition resupply routes, the specific tree lines, ravines, and farmstead ruins that Russian gun crews used as cover between fire missions. The acoustic and radar detection piece came first. AN/TPQ-36 and AN/TPQ-37 firefinder radars, supplied by the United States, could track incoming shells in flight and compute the firing location through ballistic back calculation. Against a 203mm round, the radar signature is unmistakable. The shell is large, slow compared to smaller calibers, and its trajectory is distinctive. When a Pion fired, Ukrainian radar systems often had a firing grid within seconds. The problem in earlier phases was that Ukrainian strike assets could not reliably reach targets 35 to 40 kilometers behind the line of contact. HIMARS changed that calculation, but HIMARS was initially directed primarily at fixed high-value targets. The pivot toward using HIMARS and long-range drone strikes against individual artillery systems in their firing positions, or better yet during displacement, was a deliberate doctrinal shift that Ukrainian commanders executed through 2024. The drone confirmation step was critical. Radar gives a firing grid, but a 46-ton tracked vehicle sitting in a camouflaged position among trees does not look like much from space. What closed the confirmation gap was the rapid tasking of reconnaissance drones, often fixed-wing systems with multi-hour endurance, to overfly the computed firing location within minutes of the acoustic or radar cue. If the Pion was still in position, the drone operator could identify it. That distinctive hull shape, the long barrel, the support equipment around it. If it had already displaced, the drone could follow the track marks. In broken terrain, a 46-ton vehicle leaves marks. Working through the geolocated strike records associated with confirmed Pion losses, one detail kept appearing in case after case. The strikes almost never hit the gun at its primary firing position. They hit it at the alternate position. The gun displaced, exactly as doctrine required, and Ukrainian forces had already mapped the alternate position, or they tracked it in near real time, or both. The displacement that was supposed to save the platform became the moment of maximum vulnerability. What Russia should have done, and largely failed to do, was introduce genuine unpredictability into its displacement patterns. Using pre-surveyed alternate positions is efficient. Crews know exactly where to go, the ground has been checked for soft spots and concealment, fire missions can resume quickly, but pre-surveyed positions can be identified by persistent overhead reconnaissance. Ukrainian ISR assets, operating over weeks and months, were patient enough to build a comprehensive picture of the terrain behind Russian lines. Grid references for potential firing positions were accumulated. When a Pion fired and displaced, it was often moving toward a location that was already on a Ukrainian targeting list. The first confirmed Pion loss of 2024, that Ukrainian open-source analysts documented with geolocated evidence, occurred in the Zaporizhia-Donetsk border region in early spring. Oryx cataloged the wreckage photograph, the unmistakable hull of a 2S7 series vehicle, the long barrel intact, but the fighting compartment destroyed, the track assembly blown apart, obvious signs of a precision strike rather than direct artillery counterfire. Within weeks, 2 more confirmed losses appeared in imagery shared through Ukrainian military social media channels, both in the broader Donbas operational zone. The pace accelerated through the summer months. What stands out about this pattern? Russia did not significantly change its operational behavior after the first confirmed losses. The Pion continued to be employed in its standard deep fires role, from roughly the same positional depth, with roughly the same firing rhythms. Russian units appear to have lacked either the situational awareness to understand what was happening, that their firing patterns were being mapped and their displacement routes predicted, or the operational flexibility to change those patterns even if they understood the threat. That institutional rigidity is not surprising in context. Russian artillery units at the battery and battalion level were operating under significant personnel pressure through 2024. Experienced pre-war cadres had been attrited by 2 years of intense combat. Replacement crews were trained to execute established procedures, not to improvise new ones. The doctrine said, fire from this depth, displace to pre-surveyed positions, resupply on this schedule. Deviation from doctrine required initiative and authority that mid-level Russian commanders were not exercising or were not permitted to exercise. By late summer 2024, the confirmed Pion loss count, tracked by Oryx and corroborated by independent geolocators in the Ukrainian OSINT community, had reached 7, then 9. The pace was roughly 1 confirmed loss every 3 to 4 weeks across the Donbas operational area, with clustering along the axes of heaviest Russian deep fires activity, the Avdiivka approaches, the Toretsk corridor, the areas north and northwest of Donetsk city, where Russian forces were sustaining their grinding offensive pressure. A practical question: how many HIMARS strikes does it take to destroy a 46-ton self-propelled gun designed with substantial armor protection? In most documented cases, the answer appears to be 1. If the M31A1 GMLRS rocket, with its roughly 90-kilogram unitary warhead, achieves a hit or near miss against the vehicle's hull or immediate vicinity. The 2S7 Pion was built to survive artillery counterfire, not precision-guided munitions. Its armor protects the crew against shell fragments from near-miss conventional rounds. Against a warhead designed to defeat area targets with a precision direct attack profile, the protection is marginal. In several documented cases, the strike appears to have detonated propellant charges stored near the gun, producing catastrophic secondary explosions, the kind of secondary that makes a vehicle unrecoverable regardless of the initial damage. Longer-range FPV drones also appear in the loss documentation, particularly for targets at the closer end of the Pion's deployment depth. By 2024, Ukrainian drone units had developed extended-range FPV systems capable of reaching targets 15 to 20 kilometers behind the forward line, using fiber optic guidance or relay configurations that defeated standard Russian electronic warfare jamming. A 46-ton vehicle is a large, relatively stationary target if caught in a firing position. Several of the documented losses appear consistent with drone strike patterns rather than HIMARS. The damage signature differs, with more localized penetration and fire rather than the broader blast pattern of a GMLRS warhead. The most operationally significant cluster of losses occurred in autumn 2024, when Ukrainian counter-battery operations appear to have deliberately targeted a concentration of Pion systems supporting Russian offensive operations in the Toretsk area. Within a 6-week period, at least 4 confirmed Pion and Malka losses were geolocated to a relatively compact rear area zone, suggesting either that Ukrainian intelligence had identified a specific artillery grouping supporting this offensive, or that the counter-battery hunt had become sufficiently systematic that multiple guns in the same operational sector were being serviced sequentially. If you have been following this war seriously, the Toretsk cluster matters for a reason beyond the individual vehicle count. Toretsk was the site of sustained and grinding Russian offensive pressure through the second half of 2024. Russian deep fires were essential to that offensive, used to suppress Ukrainian defensive positions, destroy fortifications, and interdict the supply routes that kept Ukrainian defenders in the city and its outskirts. The Pion was specifically valuable in that role because its 203mm round could defeat reinforced defensive positions that lighter artillery rounds were not reliably penetrating. The loss of 4 or more Pion systems supporting that offensive within a compressed time frame had operational consequences. Russian fire support planning had to account for reduced heavy artillery availability. Missions that would previously have been assigned to Pion batteries had to be redistributed to 152mm guns with shorter range, lower penetration, and less terminal effect against hardened positions. Or those missions simply did not happen. Targets that would have been serviced by 203mm fires were left unserviced, giving Ukrainian defenders time to repair, reinforce, or relocate. This is the strategic logic that makes the counter-battery hunt against the Pion more significant than a raw vehicle count suggests. Each gun removed from the Russian order of battle is not simply one fewer platform. It is a gap in Russia's deep fires architecture that cannot easily be filled. Production of new Pion or Malka systems essentially ceased with the Soviet Union's collapse. Russia has not manufactured new 2S7 series vehicles in any meaningful quantity. Attrition from the loss count means the overall fleet is shrinking, and the replacement pipeline from long-term storage, which requires extensive refurbishment of vehicles that may have sat in open storage for 30 years, is slow, expensive, and constrained by the industrial capacity Russia is simultaneously committing to producing shells, drones, and other higher priority systems. An intercepted Russian logistics communication from late 2024, shared by Ukrainian military intelligence and reported by several Kiev-based open-source analysts, referenced what appeared to be difficulties sourcing replacement 203mm gun tubes for damaged platforms. The 203mm tube is a specialized component. It is not interchangeable with anything else in the Russian artillery inventory. If a tube is damaged, either by a strike or by barrel erosion from high firing rates, the repair requires either a factory or a salvageable donor vehicle. With 15 confirmed losses and additional vehicles carrying undocumented damage, the spare parts and replacement component situation becomes genuinely constraining. The count reached 15 confirmed losses by spring 2025, with Oryx documentation anchored to geolocated photographs in each case. The 15 figure matters because of what it represents relative to the estimated active inventory. If Russia entered the full-scale war with roughly 60 Pion and Malka systems at some level of operational readiness, and approximately 15 have been confirmed destroyed with photographic evidence, the actual attrition is almost certainly higher. Open-source confirmation tends to lag and undercount actual losses, since not all destroyed vehicles are photographed in locations accessible to public imagery. A reasonable working estimate, consistent with the methodology Ukrainian and Western analysts apply to other platform categories, would place actual Pion and Malka losses somewhere between 20 and 25 systems, roughly a third to nearly half of the pre-war active fleet. That is not a fleet that has been eliminated. Russia still fields Pion batteries. They are still being used, but the operational profile has changed in detectable ways. Reporting from Ukrainian counter-battery units through early 2025 indicates that Pion firing depth has increased. Russian gun crews are positioning further back than they were in 2023, apparently in response to the demonstrated reach of Ukrainian counter-battery systems. That additional standoff comes at a cost. At maximum range, with rocket-assisted projectiles, accuracy degrades. The shells that were devastating Ukrainian defensive positions at 35 kilometers become significantly less precise at 45 kilometers. The operational effectiveness per round fired declines. The logistical burden of supplying 203mm ammunition to positions further from the forward line increases. Most people assume the solution to a counter-battery threat is simply to move the guns back further. The evidence from the Pion campaign shows that assumption is wrong in one key detail. Moving back does not eliminate the threat. It trades accuracy and operational tempo for marginal additional safety, and the safety margin shrinks as Ukrainian drone ranges continue to extend. The threat does not recede as the gun retreats. It adapts. Here is the take that will probably get some pushback. Russia's continuing commitment of Pion systems to active frontline operations in 2024 and 2025, despite documented losses, reflects not tactical calculation, but institutional inertia. A rational cost-benefit assessment would have directed these platforms to the most protected rear area positions possible, used sparingly for the specific deep strike missions that no other Russian platform can accomplish, and never placed them within realistic range of Ukrainian counter-battery systems. Instead, they were used as regular deep-fire assets in support of tactical offensive operations. The same role a 152mm gun can fill at far lower risk to a platform Russia cannot replace. That is not a decision driven by military necessity. It is a decision driven by the absence of doctrine that accounts for the environment Ukraine has built. The battle damage assessment picture, assembled from satellite imagery and ground-level photography through 2025, is unambiguous on the question of recovery. Of the 15 confirmed Pion and Malka losses documented by Oryx and independently geolocated by Ukrainian analysts, none appear to show evidence of recovery or repair attempts. Several vehicles were photographed days and then weeks after the initial strike in deteriorating condition, with no signs that Russian recovery teams accessed the wreckage. This is consistent with a broader pattern of Russian armored vehicle losses, where the tactical situation did not permit vehicle recovery, and where the assessed repair cost and time would not justify the effort. A 46-ton tracked vehicle with a destroyed fighting compartment, a ruptured ammunition compartment, and potentially a damaged gun tube requires depot-level maintenance even in the best case. Under combat conditions, with Ukrainian fires dominating the ground around the wreck, recovery is practically impossible. The cost dimension is worth examining explicitly. Open-source defense economics analysts place the current replacement cost of a 2S7M Malka somewhere between $10 and $15 million, accounting for the complexity of the platform and current Russian defense industrial pricing. 15 confirmed losses thus represent somewhere between $150 and $225 million in destroyed platform value, before accounting for the ammunition, the crew training investment, and the opportunity cost of losing irreplaceable deep fires capability. That is a significant figure even against Russia's wartime defense budget, but the monetary value understates the actual cost. You cannot simply purchase 15 new Malkas. They are not being produced. The monetary loss is secondary to the capability loss. What do you think? Does Russia's inability to replace these platforms mean the Pion loss campaign has already crossed a strategic threshold, or is the remaining fleet still sufficient to matter? That question sits at the center of current Western intelligence assessments, and it does not have a clean answer yet. Ukrainian counter-battery operators, interviewed in anonymized reporting by Ukrainian investigative outlets through 2024, described the Pion hunt as methodical rather than opportunistic. One operator, identified only by unit affiliation with a counter-battery brigade in the Donetsk direction, described building what he called a pattern library, a database of Pion firing positions, displacement routes, and resupply timing built over months of persistent ISR coverage. When a Pion fired, the acoustic and radar cue told them approximately where the gun was. The pattern library told them where it was going. In several cases, by his account, the strike was called not against the primary firing position, but against the predicted displacement route, with timing calculated to catch the vehicle moving between positions. The moment of maximum vulnerability when the gun is on the road cannot fire back and cannot rapidly seek cover. The displacement intercept tactic is the most tactically elegant element of the entire campaign. It inverts the Pion's calculated safety margin. The gun was designed assuming that displacement would save it. Ukrainian counter-battery doctrine turned that assumption into a targeting opportunity. The harder the crew worked to follow proper displacement procedure, moving promptly after firing, using pre-selected routes, the more predictable their movement became. One detail that stuck in reviewing the geolocated loss record: several of the confirmed destruction sites are not near any obvious firing position. They are on secondary roads, track junctions, and field lanes in the rural rear areas of Donetsk Oblast, exactly the kinds of routes a displacing artillery vehicle would use. The gun was caught moving, not standing still. That is not an accident. That is the product of months of accumulated pattern analysis by Ukrainian ISR operators who were patient enough to watch, record, and map before they struck. The intercepted Russian communications picture, as aggregated by Ukrainian military intelligence and selectively shared with open-source analysts, adds texture to the BDA. In several instances following confirmed Pion losses, Russian unit-level communications showed confusion about the cause of the loss, whether it was counter-battery fire, drone strike, or some other mechanism. That confusion is operationally significant on its own. If Russian artillery commanders cannot accurately assess how their platforms are being destroyed, they cannot implement effective countermeasures. Several communications referenced what appeared to be after-action discussions attributing losses to drone activity when the physical evidence is more consistent with precision rocket strike. An understandable error given the compressed time between launch and impact of a GMLRS round, but an error that would lead to the wrong countermeasures being prioritized. If you have heard about Ukrainian counter-battery successes primarily in the context of shorter-range guns and tank losses, drop a comment telling us you want a deeper breakdown of the long-range artillery campaign specifically, because the Pion story is one dimension of a broader pattern that includes documented losses of 2A65 MSTB towed howitzers, 2S19 MSTS systems, and the ongoing attrition of Russian 152mm gun parks that does not get the analytical attention it deserves. The asymmetry at the heart of this campaign is almost paradoxical in retrospect. The 2S7 Pion was Russia's answer to a specific problem. How do you strike deep into enemy rear areas when shorter-range artillery cannot reach? Ukraine's answer to the Pion was not a comparable deep-strike gun. It was a system of systems, sensors, data fusion, strike assets, that collectively reached further and faster than any single artillery platform. A Pion costs perhaps $12 million and takes years of specialized training to crew. The drone reconnaissance assets that mapped its firing patterns cost a fraction of that. The counter-battery radar that detected its shots is a gift from the United States. The HIMARS rocket that struck it down costs roughly $160,000 per round. The cost-exchange ratio is deeply unfavorable to Russia, and that ratio gets worse with every platform in Russia's limited Pion inventory that is removed from the order of battle. This is not unlike the exchange mathematics that characterized the Gulf War, where coalition forces systematically dismantled Iraqi air defense and artillery systems at cost ratios that made continued Iraqi resistance in the open essentially impossible. The parallel is imperfect, Ukraine's campaign has been slower, grinding, and conducted under conditions of active Russian counterpressure that the Gulf War coalition never faced. But the underlying dynamic is recognizable. A technologically inferior adversary attempting to employ legacy platforms against an opponent who has integrated modern ISR and precision strike into a coherent kill chain. The history suggests that the side with the kill chain eventually wins that specific competition. Does the pattern repeat here? Look at the wreckage photographs and form your own judgment. The battle damage assessment as of spring 2025 shows 15 confirmed Pion and Malka losses arrayed across the Donbas operational zone, with the heaviest concentration in the Toretsk-Avdiivka-Donetsk city arc, where Russian offensive operations have been most sustained. Independent geolocators have verified the coordinates of 12 of these sites to within approximately 50 meters using building shadows, field boundary alignment, and road geometry visible in satellite imagery. 3 additional losses are confirmed from photographic evidence, but have not been independently geolocated with the same precision, pending higher resolution imagery of the relevant areas. The Ukrainian General Staff's periodic equipment loss announcements have referenced 2S7 series systems on multiple occasions through 2024 and 2025, with the announced figures running somewhat ahead of the independently verified Oryx count, a consistent pattern across all platform categories that reflects the difference between claimed and photographically confirmed losses. Western defense officials briefing on Russian equipment attrition have not specifically broken out Pion losses in publicly available statements, but the broader picture of Russian artillery attrition they have described is consistent with an accelerating loss rate across all heavy artillery categories through 2024. What remains is the question of Russian adaptation, or the absence of it. By spring 2025, there are limited signs that Russia has significantly modified its operational employment of remaining Pion and Malka assets in response to the documented loss rate. Firing depth has increased, as noted. There is some evidence of more frequent position changes and reduced standardization of displacement routes. But the fundamental vulnerability, a slow, heavy platform that must return to predictable terrain features to find adequate concealment and firing positions, has not been resolved. You cannot solve a displacement speed problem on a 46-ton legacy platform with a doctrinal memo. The physics are fixed. The terrain is fixed. The Ukrainian ISR infrastructure that now covers the Russian deep rear in the Donbas is not going away. The guns that remain in Russian service are operating under tighter constraints, with more careful crew management and presumably higher leadership attention to their protection. Whether that increased caution translates to reduced operational effectiveness, fewer fire missions, more conservative positioning, longer gaps between batteries, is a question that Ukrainian counter-battery planners are better positioned to answer than any open-source analyst. But the logic of the situation suggests that yes, the remaining Pion crews are more cautious, fire less frequently, and accept more positional constraints than they did before the loss campaign matured. A gun that fires less frequently at greater range and reduced accuracy has been operationally degraded, even if it has not been physically destroyed. Could Russia have prevented this? Almost certainly yes. If it had recognized the threat earlier, introduced genuine unpredictability into its firing and displacement patterns, invested in counter-drone coverage of its artillery rear areas, and reserved its Pion and Malka systems for the specific deep strike missions that justify their risk rather than using them as general fire support. None of those adaptations are technically impossible. All of them require the kind of agile, bottom-up tactical adaptation that Russian ground forces have consistently struggled to execute at scale in this war. The institutional rigidity that made the Pion vulnerable was not a failure of equipment. It was a failure of organization. How does this change the picture for NATO planners studying the lessons of this war? The Pion campaign provides a template that goes beyond this specific platform. Any heavy, slow, legacy fire support system and several NATO adversary inventories include comparable platforms, faces the same fundamental vulnerability when confronted with a mature, integrated ISR and precision strike kill chain. The lesson is not specific to the 2S7. It is a general statement about the viability of Cold War-era artillery doctrine in an environment where persistent overhead reconnaissance can map firing patterns and where precision-guided munitions of modest cost can reach targets at depth. NATO planners will note, and Russian planners should note, if they are assessing this honestly, that the counter-battery campaign against the Pion succeeded not because Ukraine deployed some revolutionary new weapon, but because it integrated existing sensors and strike assets into a coherent, patient, and systematic process. And what is the next Russian deep fire's target in Ukraine's counter-battery queue? The 2S4 Tyolpan self-propelled mortar at 240 millimeters presents a similar profile. Slow displacement, identifiable acoustic and radar signature, irreplaceable in significant numbers, and increasingly documented in open-source loss tracking. The TOS-1A thermobaric multiple rocket launcher, while shorter-ranged, has appeared in Ukrainian counter-battery strike footage with increasing frequency. The longer-range 2S5 OSINT S at 152 millimeters is a less exotic target but present in larger numbers, and the same kill chain methodology that worked against the Pion can be applied against any system with predictable firing and displacement patterns. Whether Russian commanders will find a way to break those patterns before the attrition curve reaches a level that genuinely degrades their operational capability. That is the open question that the next 6 months will answer. 15 Pions confirmed. The count is still rising. And the operators watching those screens in Donetsk Oblast are still patient, still building their pattern libraries, still waiting for that heavy barrel to elevate before the clock starts running. If the systematic attrition of Russian artillery at depth is the kind of OSINT investigation you want more of, subscribe to Frontline Truth UA. Every week we reconstruct the kill chains, map the losses, and examine what the open-source evidence actually shows, not what either side claims. The next investigation is already in progress. You should be here for it. 3 questions before you go. Could Russia have preserved its Pion fleet if it had simply refused to use these platforms in direct fire support roles and reserved them for the rarest deep strike missions? The answer shapes everything we think about how Russia allocates irreplaceable legacy assets going forward. How does the demonstrated effectiveness of the integrated ISR plus precision strike kill chain change what NATO needs to invest in, and more urgently, what it needs to defend against if this methodology is ever turned in a different direction? And finally, Russia still has Pion and Malka systems in the field. Ukraine's counter-battery campaign is ongoing. Where does the count stop, and does Russia see the next strike coming before it lands?